In this chapter, we learn about the Thevenin's theorem. The main purpose of the Thevenin's theorem is to reduce the complex network into a simple network. That means in a network we have so many resistors and a voltage source. We can simply calculate those all resistance into a single resistor and a single voltage source. Thus we can calculate the current flow in a load resistor using single resistance and a voltage source. This is the main purpose of the Thevenin's theorem. In this example, we have three resistors R1, R2, R3, which are shown in the figure, and a voltage source and a load resistors. These three resistances R1, R2, R3 is calculated as simply as R Thevenin's, RTH, and the voltage source is VTH. Actually, what the Thevenin's theorem states that in any linear network consisting of voltage source and resistances, if viewed from any two terminals in a network, that can be replaced by an equivalent source V Thevenin's in series with an equivalent resistance R Thevenin's. That means total combined resistance is given as a R Thevenin's and a voltage as V Thevenin's. This we can clearly understood by using this pictorial graph. Suppose there is a linear network with source and resistances and a load resistors. This can be simply drawn as single voltage source and a combined resistance of all resistances as a R Thevenin's and a load resistance. Thus we can simply calculate the current flow in the load resistance as IL equal to V Thevenin's by R Thevenin's plus RL. Here V Thevenin is equal to Thevenin's voltage that would appear across the terminals AB with no load connected across AB, and R Thevenin is equal to Thevenin's resistance across the terminals AB with voltage source short circuited. The steps to solve the Thevenin's theorem are: step 1, remove the load resistance RL from the circuit and short circuit the voltage source and then draw the circuit. In the step 2, determine the V Thevenin's, still RL in removed condition, and short circuit the voltage source. Number 3, step 3, draw the Thevenin's equivalent circuit and reconnect the load resistance across the terminals and then calculate the load resistance.